So for this exercise, we want to find the region shaded here in blue. So as we can see, this is the polar curve, and we got to find this whole thing, but we really don't want to find this. So we're going to have to subtract that area somehow. So my strategy will be going from here to here, and then multiply by 2, since we have some symmetry across the polar axis. Alright, so how do we find these coordinates? So this one should be pretty straightforward, since theta is equal to 0. We can confirm that, so we have to get an r equals 3 when we plug in theta equals 0. So we go r equals 1 plus 2 cosine 0, remember, because we're plugging in theta equals 0. So r equals 1 plus 2, r equals 3. So yeah, that checks out. So our theta is going to be equal to 0 there. And then now we're going to want to find this coordinate, what theta is here. So notice that the curve crosses it here first, then it does a loop-de-loop, goes back there. So we should get 2 coordinates there. In reality, it's actually an infinite number of coordinates, but from 0 to 2 pi, we should get only 2 coordinates. So let's find them. So we know that r has to be equal to 0 since we're in the origin here. So 0 is equal to 1 plus 2 cosine theta. Notice that I substituted 0 for r. So 0 is equal to, or I can just pass the negative 1, 2 plus 2 cosine theta. Divide by 2 both sides. Negative 1/2 is equal to cosine theta. Okay, so notice that this angle is negative, so let's draw the unit circle. So it has to be here, since cosine is negative. Cosine. Alright, so we know that pi over 3 has the coordinates of 1/2 square root of 3 over 2. Alright, so it has to be the pi over 3 that's here, and the angle that has a reference angle of pi over 3 that's also here, in the third quadrant and the second quadrant. The one in the third quadrant, the second quadrant, is 2 pi over 3. The one in the third quadrant is just 4 pi over 3. Alright, so that means that the first time it hits here, it should be 2 pi over 3. The first time. And then it goes around this loop-de-loop, and it hits it back at 2 pi over 3. This is the second time. I'm sorry, at 4 pi over 3. Alright, so we got 2 pi over 3 and 4 pi over 3. So, now let's finish it up. Let's finish this up. Theta is equal to 2 pi over 3 or 4 pi over 3. Alright, so if we want to establish this integral, so notice that we have to take into account going from 0 all the way to here, which the first time we said that's 2 pi over 3. So the first integral should be from 0 to 2 pi over 3. And remember that we use the area of a sector, so it's 1/2 r squared times an angle. But since we're using an angle here, we want it to be infinitesimally small, so we use d theta. So we need a 1/2 here, and r squared, so r is this. Let's copy paste it. Alright. So we've got r is equal to 1 plus 2 cosine is theta here. Alright, okay. So this is 1, but notice that I'm only getting the area from here all the way to here but not really neglecting. I'm neglecting the fact that I have a loop-de-loop here, and I don't really want this area. So right now I'm including that area. So to illustrate it, you can go to Desmos, see what's going on. And let's say we want to go from 0 to 2 pi over 3. So 2 pi over 3. So yeah, and notice that right now this integral, we're calculating this entire area. So we're not really taking into account the loop-de-loop that's going on here. So right now, if we do this, it's wrong. So I'll remember that the strategy is like we calculate this area and then we multiply by 2. Alright, so we need the loop-de-loop, or at least part of the loop-de-loop, so we can neglect that area. Alright, so the part of the loop-de-loop that we actually want is, we'll just get a new graph here. Actually, I think I have it here. So the part of the loop-de-loop that we actually want is just from here to here. So we already know that the second time it hits here, it's 4 pi over 3. We calculated that. And so what's this angle? So notice that this angle is in the polar axis, and it can't be 0. Why can't it be 0? So we already proved that when we substitute theta equals 0, our r should be 3. So our r is here. So why not plug in pi? So let's plug in pi. 1 plus 2 cosine of pi. 1 plus pi. Negative 2. It's negative 1. So we're getting a negative radius. But remember that with pi is actually here. And with polar coordinates, when you have a negative radius, it gets reflected. So in reality, the polar coordinate of negative 1 comma pi is actually here, or here. So theta is equal to pi here. Alright, so we want to neglect this area. So we know that's from pi to 4 pi over 3. Alright, so minus the integral of pi to 4 pi over 3. And it's the same thing, 1/2, I forgot a squared here, 1 plus 2 cosine theta squared d theta. But right now, we're only calculating this part, the top part only. And we want to calculate both. To do that, we need to multiply by 2. Alright, so we can multiply the whole thing by 2. So distributing with this 2 will cancel with this 1/2, and this 2 will cancel with this 1/2. So we can just write the integral of 0 to pi over 3, 1 plus 2 cosine theta squared d theta minus the integral of pi to 4 pi over 3, 1 plus 2 cosine theta squared d theta. So since these integrals are the same, what I'm going to do, I'm going to solve one of them and then just use the values to plug them in. Alright, so let's say 1 plus 2 cosine theta squared d theta. I'm going to solve the indefinite integral first. Alright, so this is 1 plus 2 times 1 is 2. Multiply that by 2 is 4 cosine theta plus 4 cosine squared theta d theta. So 1 plus 4 cosine theta, I can't really integrate this yet. So I'm going to have to use my half angle formulas. 1/2, 1 plus cosine 2 theta d theta goes here. This is a 2 now. 1 plus 4 cosine theta plus 2, 1 plus cosine 2 theta d theta. I'm going to distribute this now. 1 plus 4 cosine theta plus 2 cosine 2 theta d theta. So now we have these two like terms, so I can add them up. Integral of 3 plus 4 cosine theta plus 2 cosine 2 theta d theta. Alright, so now I can actually integrate. This 3 theta plus 4 sine theta, because the derivative of sine is cosine, plus 2 sine 2 theta over 2, so these two cancel out. So the indefinite integral be 4 sine theta plus sine 2 theta. But first, let's evaluate this one from 0 to 2 pi over 3, these two. Okay, so let me just copy this. That's saved. So we said from 0 to 2 pi over 3. So notice that at 0, everything turns to 0. So let's just plug in 3, 2 pi over 3, 4 sine of 2 pi over 3 plus sine of 4 pi over 3. So here, 3 times 2 is, well, I can just cancel these, so we get 2 pi plus 4. So sine of 2 pi over 3, so now 2 pi over 3, the coordinates are these two. And since we're in the second quadrant, sine of 2 pi over 3 must be positive square root of 3 over 2. So we get positive square root of 2 over 2. Now, here we're in the third quadrant, so it should be negative square root of 3 over 2, the y coordinate. So negative square root of 3 over 2. Now, notice that these two are the same. So I can just say that 4 oranges minus 1 orange is 3 oranges. So it's 3 square root of 3 over 2. So this is this part right here. Let's do the same thing, but with these bounds of integration. So it's pi to 4 pi over 3. Pi to 4 pi over 3. So you plug in this one first. 3, 4 pi over 3 plus 4 sine 4 pi over 3 plus sine of 8 pi over 3. Yeah. So when we notice that, it's going to be 3 pi plus 4 sine of pi. But luckily for us, these two go to 0. Because sine here is 0. Alright, so we got lucky there. So I can cancel these two. I'm going to get 4 pi plus, so this negative goes here. But first, let's do 4 pi over 3. So we said that at 4 pi over 3, which is here, sine should be negative. And here we have 8 pi over 3, so notice that 8 pi over 3 is bigger than 2 pi. So I can just find the reference angle. 3 times 1 is 3. 8 pi minus 6 pi. So this is equivalent to 2 pi over 3. So if I can find whatever 2 pi over 3 is, whatever sine is of 2 pi over 3, it's equivalent to 8 pi over 3. Alright, so sine of 2 pi over 3 is just the square root of 3 over 2. So notice that these two will turn into just a pi. So it's pi. These two will cancel. I'm going to be left with a 2 there. So minus 2 root 3 plus root 3 over 2. Or in reality, I think it's even better if we just left this. So negative 4 root 3 over 2 plus 3 root 3 over 2 is just negative 3 root 3 over 2. So this is my answer for that integral. So if we plug in the answers, we're going to get this minus this. But remember that this applies to everything. So we're going to get 2 pi plus 3 root 3 over 2 minus pi plus, so this goes over here, 3 over 2. So this pi and this pi end up being just a single pi. And 3 root 3 over 2, if I have two halves, if I add two halves, it'll make me one whole. So it's just 3 root 3. So this is the answer that I'm getting right now. Pi plus 3 root 3 over 2. So let's plug this into a calculator and see if we got the right thing. Pi minus 3. So I can just say this is the integral of, I'm going to neglect the 1/2 since they cancel out. 1 theta squared d theta minus the integral of pi to 4 pi over 3 I'm missing a 2 here. Oh, there it is. My bad, I'm sorry about that. So yeah, it seems like it's correct. It checks out. Thank you for watching.